This is a short motivational video on Newton's method. Newton's method is a method to take a given function. This function that's highlighted here in blue is the blue function that is plotted down here below. The idea of Newton's method is to try to come up with an algorithm to find that point right there, the zero of a function, and this algorithm takes a starting value, this black dot, which we'll call x0, and runs through an algorithm to approximate or find the numerical solutions to the zeros of a function. This demo is meant to just kind of show how the method works graphically, and then just show some of the numbers. In a follow-up video we'll show the pencil and paper work. So here we're seeing Newton's method in action. Let's see, here's our starting value x0. Okay, we've chosen a starting value of 4. The idea of Newton's method is to find your way up to the function over the value of x0. So here's a point on your function, and then to draw the tangent line at that point, and then the tangent line will eventually cross 0. Okay, that would be the first step of Newton's method. Where the tip of this red arrow will be your new black dot, and then you will run the function that from this point up to the function and draw another tangent line. Okay, you'll go up from this point, draw your tangent line, and the tangent line will have another 0. Okay. And then the idea is to go a third step of Newton's method, which would read up to the function, draw a tangent line at this point, and then find the 0 of that function, of that tangent line. You can see that this step we're getting bouncing and bouncing and getting closer and closer to the 0 that we were interested in right here. So Newton's method is just a series of drawing tangent lines and solving the tangent line equal to 0. Here are the 4 numbers that we drew in the picture. 4 is our starting value. 3.6 was the place that our tangent line first crossed the x-axis, the y-axis, so that's the first 0 at a value a little bit to the left of 4 at 3.16. Run Newton's method again. The next tangent line crosses at 2.68, which is a little further to the left, and you do this enough times and you will get closer and closer to a number. That number 2.4142 looks to be about what the 0 of the blue function is. Okay, so there's a graphical interpretation, a graphical method for how Newton's method works. Let's put the first step of the process together and show the math that could be involved there. Up here, this is my calculator, we have taken the function and we've evaluated it 4. So we've taken this function that we were trying to find the 0 of, and we've put in our starting value of 4. 4 was just a guess, we picked one. The value of the function at 4 is 21. We can see that corroborated on the graph down here at about the height above this value of x is 4, the y value is about 21. Okay. The next thing you need is to find the derivative at 4. Take the derivative of this function evaluated at 4 and you will get the number 25. Okay. Then in this picture we needed so the 25 makes sense. The slope of this line is a positive number. The derivative is the slope of the tangent line. The next step was to write down the tangent line. F of 4 plus f prime of 4 times x minus 4 is the equation of the tangent line. Okay. And then you're going to solve that equation equal to 0. Solve it by hand on paper. I've chosen to use my calculator to solve it. But when you solve that tangent line equal to 0, we're finding this point right here, and that gives us an x value of 3.16. And that was where this point came from. Okay. Newton's method, we could continue the algorithm. Okay, if we continue the algorithm, we would just run this through for more steps. How do you get all the numbers that are showing up above here, right? Each one of these represents one step of Newton's method. Here's the first step of Newton's method. The second step should give us this number, and the third step should give us this number. So let's go through the steps just using my version of a calculator. Okay. So the idea was to start with your function, and you have to start with a guess value. We've chosen 4. So the first step that we did was find f of 4, f prime of 4. We found the tangent line, we solved it equal to 0, and we got an x value of 3.16. Okay, that was what we got from the step above. What we need to do now then is find the function at 3.16. You need to find the derivative at 3.16. You need to find the tangent line at 3.16 and put in 3.16. Here is your tangent line at 3.16. You want to find when the tangent line crosses the y-axis, x-axis, and therefore you're going to solve this equation equal to 0. And what do you find? Well, you get 2.68 as your second value from Newton's method. Okay. To go to a third value of Newton's method, you take the previous value that you just found, find the function value, 2.68, right? Find the derivative at 2.68, find the tangent line at 2.68, find the tangent line at 2.68, filling all 3 entries, and you're going to solve that equation, tangent line equal to 0, and you get 2.46. So we ran 3 steps of Newton's method using the function value, the guess of 4. You then took the answer from step 1, which was 3.16, ran the process again, took your answer that you got from the second step of 2.68, ran it again, and those 3 numbers are the 3 numbers that we got from our picture. Okay. There's the 3.16, 2.68, and 2.466. So if you continue that process, you will come up with the Newton's method algorithm. Okay. Just a hint at some of the difficulties with this algorithm. We can change the starting value, right? If you change the starting value, getting it closer and closer, maybe to what you think the answer is going to be, the algorithm will still work, okay? But there are times, I'm just changing the axis here, as I change to a different starting guess, this starting guess of 2 looks like it'll still get close to the actual 0. But if you, sometimes Newton's method can have problems. Right, let's see here. This one goes to the starting guess approaches this particular 0. Okay. But you can have difficulties for different starting guesses. Let's see, I thought there was a difficulty here. No, actually I'm not seeing any difficulties. For these different guesses, right, they go to, the algorithm goes to the root there. This starting guess, run the algorithm, you'll get close to 1. This one looks like it's on its way to going to, after 6 steps, on its way to going to the solution. Okay. So this is just a motivation that of Newton's method. We'll do another video where we show all the handwritten work. But the essential idea here is that Newton's method is finding a 0 of a given function and you're running an algorithm by changing the starting value. And if you run the tangent line process, solving the tangent line equal to 0, keep running this process, eventually, like in this example, the algorithm will get closer and closer to the 0 there at 2.414 something. Okay, so that's the end of this motivational video.